uncertainty principle is the last planned lesson in this class on physics. But before I start that, it was on purpose that I put the double slit experiment and the Heisenberg uncertainty principle towards the end, because the double slit experiment was a perfect bookend, if you will, with my first class, which was on absolute reality versus relative reality, which is, to me, simple to understand, whereas the double slit experiment was very difficult to understand. And remember what Einstein said and others, that simplicity is sometimes the better of the two. And of course, it's more logical to think. They painted themselves in the corner in that aspect, as far as I'm concerned, when they have to take one particle, but they know that the light is a wave. So how does one particle become a wave? It has to go through two slots at the same time to interact with itself, so it has to be here and there at the same time, and that just seems a little bizarre. So I think that the explanation of understanding the cause and effect in association with the connectivity of the ether, which is my primary phrase, is in accordance to Newtonian understanding of the connectivity of everything, is the better answer to that. It's more logical answer. Um, so I did that on purpose with the double slit experiment, and now follow that up with the Heisenberg uncertainty principle. Now, as far as the Heisenberg uncertainty principle, there's a lot of things I've said that are in physics that I believe, and what I disagree with is sometimes their explanation of the phenomena. Now, in this regard, I do believe that the Heisenberg uncertainty principle is beneficial as far as the probability perspective is concerned. What I want you to do is, on the screen here, you'll see this explained and simplified position of momentum. This is a video on YouTube. The address is down below. Go and visit this and look at this. It really is somewhat of a simplified understanding of the probability perspective of the Heisenberg uncertainty principle, which I'm in total agreement with. Now, there's one word that they used I wish they hadn't used towards the end, is randomness, because I do not believe anything is random, and I'll talk more about that in a minute. So if you can, just stop this video, go and view this YouTube video, and then come back and we'll discuss it some more. So why is it important that we have some ability to quantify, to use probability to try to determine where a particle is? Well, especially becomes important in quantum computing. For instance, in regular computing, we have ones and zeros that have to be arranged in a certain specific order in order to make sense and to make code. So in order to do that with the quantum computing, you have to know where the particles are in order to arrange them in a certain organized fashion to make sense. If that can be done, and I think it perhaps can be, then it'll save a lot of energy, plus it'll be a whole lot faster. But the problem is that this probability, you've got to get the probability to parameters down within a workable space in order to be able to control or manipulate these particles in order to have a meaningful data code. So hopefully you can understand that, but I do believe that there's a possibility that that can be done. But it has to be able to have the probability down to a specific preciseness. Now, some aspects of the Heisenberg uncertainty principle, when you talk about this thing called randomness, because it's so difficult to try to pinpoint something, and even this understanding of the variables as far as probability and just getting it within certain parameters. I'm going to give you a mind example that perhaps Einstein would do. This is going to be an extreme example of why I disagree with some of these things. Let's suppose that there's an infinite number of video cameras, and each of those video cameras can take an infinite number of frames per second. and each of those infinite number of video cameras are pointing in an infinite number of directions, and each of those video cameras have the ability to clock speed a speed gun associated with it, so you can determine the speed of these any particle. And in addition, there's an infinite number of horizontal lines and vertical lines to make an infinitely small speck or a box, like a pixel, to infinity. And so when you think about this, we can take a particle, shoot it any direction you want to, and we can track it with these video cameras and know exact speed and exact position at any particular time to infinity. So that kind of blows this whole thing as the uncertainty principle. It's not really uncertain, it's just that we have a lack of infinite data, and we have the lack of infinite ability to use the techniques or the apparatus in which to observe. Now, even the observation, remember we talked about detection when in the double slit experiment, when you detect something, light beam has to go out to that particle and come back in order for it to be detected. And that's part of that uncertainty, because the detection itself affects the outcome. Well, in this case, the detections is from all different directions. It would be the same as saying out there in the void, the perfectly and evenly balanced particles in the in this ether field. It has what I'm proposing is these video cameras are in infinite directions, so each particle is being hit infinite directions with the same detections, so it's no detection is affecting it any more than any other one, but you can look at any of these detections and get it from any perspective. I hope you understand that, so that the particle is not being affected by the detection of it by any of those detectors, because there's an infinite number of detectors from all different directions, so they all have the same effect on it, so there's a balanced effect. I hope you understand that. It's a little wild. This is really impractical. This is a very extreme example to get to the understanding that there's no such thing as randomness. There's no such thing as yes, detection does affect the outcome, so that's why it becomes somewhat uncertain. But without that detection, nothing is random. Nothing is uncertain. So the randomness becomes, or the uncertainty becomes, part of this understanding of the ability to detect. And so I'm quite aware of that, but this is just an absurd example to show you that without the detection, nothing's random, nothing's chance, nothing's uncertain. Only we cause it to be uncertain with our detection, causes it to be to change. So now we come to my final point, and the thing that wraps this all up is there's no such thing as randomness. There's no chance. There's no uncertainty. Everything is balanced. Everything is certain. That's why I know for sure that there is this understanding of balance. This is a balanced universe, a cause and effect and associated with the connectivity to ether. But once you get the grasp of a balanced universe, it takes away the randomness, the chance, the uncertainty. Only we as humans, through our observation and through our interaction, can change and cause some uncertainty, but even that is balanced through this ether reality. So I just want to make sure that I finished with that, that the balanced aspect of all of this takes away all the uncertainty. It's only through our observation, through our detection, through our manipulating or being involved, that changes it for us. So in the reality, the visible reality, some things may look like it's uncertain, chance, chaos, but if you understand the ether field, it keeps everything in balance. Everything is in balance. So you don't have to worry about anything falling apart. Everything is in balance. And it's, to me, uh, all part of this organized order in an ordered universe. Well, I hope you've enjoyed this, and thank you. It may be possible one day that we will be able to determine the effect that our detection has on any particle. That way we will take out that uncertainty. So that's all it boils down to, is our ability to understand how our detection is affecting that particle or whatever we're observing, so that we can take out that uncertainty in our equations and in our thinking. Okay, just to kind of wrap up one point before we end this class on physics, um, I want to talk about 0 point energy, which I mentioned before, which is also seems to be associated with this thing that some refer to as vacuum energy. They know that there's energy there, but they can't explain it. Well, I can, and I've already explained it. My explanation for this is what I call potential energy. And they say, well, how do you know that, John? Well, let's go back out to the void, because, again, when we're looking at the visible reality, it gets so complicated because there's so much happening. But if you go out in the void, it eliminates a lot of this noise. So in the void, the particles, these hydrogen atoms, are perfectly and evenly spaced apart. And in the ether field, according to Newton and Einstein in particular, they said there is no movement. These particles cannot move. The ether does not move. So the ether is the absolute, and these particles are the absolute. Visible reality flows through the ether, but the ether itself does not move. So if you can think of these particles as not moving, and their potential energy, so they are not receiving or absorbing energy at that particular time until they're interacted with the visible reality, and they become visualized energy, realized energy. So I hope you understand that. I just wanted to tie that one loose end up as far as 0 point energy, and what I've come across as this vacuum energy is what I refer to as potential energy. And potential energy is possible because the ether does not move. Those particles are not moving, and they are not absorbing or releasing energy. Therefore, they are the same as what they would refer to as 0 point energy and vacuum energy. I just want to clear that up before I ended this class. So again, if you remember nothing else in this class, just remember that cause and effect and association with the connectivity to ether is the main point that I want to get across. That I believe that all these people from Aristotle, Plato, I've listened to them before, but especially Newton, Tesla, and Einstein. And so I think I have some pretty good company, and I stand firm on what I've presented in this class. And I hope it helps you understand, and it'll tie in with some of the things we'll be talking about in some of the other classes. Thank you. And now you know more of the story. Stay tuned. This is John McCamick with Truth University. Good day.